So we said in this class we're going to focus on working in the SI metric system, or the MKS system. And so the next thing that we want to add in terms of understanding about units is the difference between what are known as base units and derived units. So the idea here is that every single unit within the SI system can be built up out of 7 base units. And the 7 base units are listed here in this table. So they're the units for length, mass, time, temperature, electric current, the amount of substance that you have, and luminous intensity. So any unit that you're going to deal with in the SI system can be built out of these base units, right? Now, we've said that the SI system is also known as the MKS system, and again, that MKS is helping you, or is giving you a clue about what the base units are for length, mass, and time. So in the SI system, the base unit for length is the meter. The base unit for mass is the kilogram. The base unit for time is the second. So there's your MKS, meter, kilogram, second system. Okay? Temperature, the base unit for that is Kelvin, even though we'll often work in centigrade or Celsius in a different centigrade system. But we know how to convert from Kelvin to Celsius. Again, we're going to build up a lot of stuff in the second semester class with electricity and magnetism. The base unit that almost all that's going to be built off of is the Ampere, right? And that's the base unit for electric current, so how charge moves. The amount of substance, well, this one becomes, you've probably dealt with this particular unit most in terms of doing ideal gas law problems, right? So the mole is the amount of substance. And so dealing with an Avogadro number's worth of stuff is defining what the mole is. And then luminous intensity is a measure of the power of light, right? So we can build. So these are the base units, and we can build any other unit out of these. And so anything else that we're going to build, we're basically going to derive those units using some equation to create a new unit within the SI system. So when we think about derived units, there are a couple rules that sort of apply. The first is that units follow the rules of algebra. So if you've got meters over meters, that cancel. If you've got meters times meters, that's meters squared, right? So the basic units of algebra that we already know, we can use those for units. And then the second thing is that we're going to be able to take an equation that helps define a physical quantity and think about the units in that equation to derive the units for some new quantity, generally in terms of their base units. So as an example, if I want to think about the physical quantity of area, well, I have an equation for area that says the area is the base times the height. Notationally, when we use these little square brackets, right, that notation means that we're talking about the units of a particular quantity. So when I say the units, and in this case the SI units of area, well, that's going to be the SI units of the base of some object, that's a length, times the SI units for the height of some object, that's also a length. So I get area by taking length times length in terms of units. And so in SI, the base unit for length is the meter. So I'm going to take meters times meters, and that gets me meters squared. So the base unit, or the SI unit for area in base units is meters squared or square meters. Those are two ways to say exactly the same thing. There's another example. We're going to talk a lot about speed. And again, speed is defined as a distance per time, right? So you're going to take some distance divided by some time. That's going to give you a speed. So if I want to think about the units of speed, well, the units of distance, again, that's the units of length. So distance has dimensions of length, so I want those units. Divided by time has dimensions of time, I want the units of time. The units of length in SI, in the SI system, is the meter. The units of time is the second. So in base units, speed is given in meters per second. So if we come back to that table that we looked at in the previous section, where we were talking about units of mass, force, and energy. Well, if you sort of look at this bottom, so the first thing we'll notice is that one of those is simply in a base unit, right? Mass is one of the base units, and so again in the MKS system, kilogram is the base unit there, gram is the base unit for mass in the CGS system, pound in the pound mass system, slug in the pound force system, right? So that line in this table is giving me a base unit. If you look down in the bottom right corner, however, you see what happens to be a derived unit, right? So in the English system, and let's just focus on in the pound force system, the foot is the base unit for length, the pound is the unit for force, and so what this unit foot pound is telling me is that energy in some capacity has dimensions of length times force. Okay? And so we can play that same game in terms of thinking about derived units all over this table. So let's just take a particular example with Joule. Again, what we'll see is there are equations that we can use to figure out what the SI units for energy are in base units, and it works out that that happens to be kilogram meter squared per second squared. We can take a different equation and we'll figure out that we can also write the SI units for energy as a Newton meter, right? Part of this works out because in base units, the Newton is a kilogram meter per second squared. So to get kilogram meters squared per second squared, I'm taking a Newton and multiplying it by a meter. So here are two options for the way that I can report energy in an SI unit. The third is obviously just to give it in joules. So here are three ways. These are three perfectly acceptable units in the SI system for reporting energy. And so we want to be comfortable with both sort of being able to derive what units are, and then going back and forth between sort of these various versions of derived units, maybe in terms of base units, maybe in terms of what we've renamed them, maybe in this sort of hybrid mix, right? So Newton meter is a base unit, but Newton is a derived unit. So we've got kind of this hybrid unit there in terms of it's not purely base, it's not just a derived one. So we want to sort of make sure that all this, we understand what's going on in terms of keeping track of what these units are telling us.